Welcome. Now, just to recap from our last video, what we had a table Y, which represented the total claim amounts for 5 fleets of buses over a n-year period, and that's our table. So there's our 5 fleets, A, B, C, D, and E, and over those 6 years. So for example, in 2005, fleet A, we had 1,250 claims. We also had a table P, which represents the number of policies for each risk each year over any year period. What we do is we call the fleets, we call a fleet a risk, because it can generate claims. So we had P, which was our table representing the number of policies for each risk in each year over the same period. So again, you can see that for A there were 5 policies, risk A. For risk E in 2007 there were 8 policies, and so on and so forth. Now the problem we were trying to solve is we wish to calculate the credibility premium. That is the expected cost of claims in the coming year, based on this history of 6 years. So first, we had to calculate the mean claims per policy for each risk, which we called XB. To do that, we needed YT, the total claim amounts for each risk, a PT, the total buses for each fleet, and YB, the total claims in all the fleets of buses, and PB, the total buses in all the fleets of buses. So we started off with YT, which is the total claim amounts for each risk, and that was found by calculating the row sums of Y, and so we got this result. So for example, in all the 6 years, there were 8,250 claims for risk A. In all the 6 years, there were totally 36,450 claims in risk E. Then we calculate the total buses for each fleet, which we did by finding the row sums of P. And so we can see there's the total buses. So there are 30 buses in fleet A, there are 53 buses in fleet D, and so on and so forth. Then next, we had to find the total claims in all the fleets of buses. So that was basically just adding up together everything in YT, which gave us 112,050, and then we had to find the total buses for all our fleets combined, and that of course we're just finding the sum of PT, which is 226. After that, it's easy to find the mean claims per policy for each risk, because that was just YB divided by PB, and that gave us 495.7965. So the next thing we want to do is we want to calculate the mean of the variances of claims per unit risk volume. So to do that, we needed X, which is the claims per unit of risk volume, XT, the mean claims per policy for each risk for each fleet, RV, the row variances from XT, so it's the variances from the mean XT means of claims for unit risk volume for each risk. So to calculate X, that was easy, that's just Y over P. To calculate XT, that was just YT over PT. Now we need to know the number of years, which is the number of columns in our table Y, and then to calculate RV, we used this formula: row sums of P times X minus XT squared, and then divided by n minus 1, which you should recognize as the formula for variance. And then to find the mean of these variances, we used the mean of RV. Now, the next thing was to calculate the variance of the means of the claims per risk volume. So that we needed the row variances from XB. Notice in the previous one we had the row variances from XT, Now we're having the row variances from XB. So that's our overall mean. Then we need to calculate something called P star, which is an adjustment value which used to make our estimate unbiased. Because if you remember from your variance, there's when you're doing estimation, you can have a biased estimate or you can have an unbiased estimate. And generally, we prefer our estimates to be biased. So if we didn't use P star, then we'd have a biased estimate. So but by using P star, we get an unbiased estimate. So let's calculate. We need the number of rows, which we put in big N. So that's basically the number of risks we have, or the number of fleets. And then calculate P star using this formula. P star is equal to the sum of PT times 1 minus PT over PB, all divided by N times N minus 1. Then we calculate RW, which is row sums P times X minus XB. Notice that and that, compare those two, squared, and that gave us this. And then our actual variance of the means is found by the sum of RW divided by N times N minus 1 minus S divided by P star. And that gives us 66,773.4. Okay, now the point of calculating these things was in order so that we could now calculate the credibility factor. Because remember, what we're trying to do is we want to find out what our claims will be in the coming year. We want to estimate it. We want to try and predict it. So we need to now predict. We need to now calculate the credibility factor for each risk, and that is found by Z. That's Z. We'll call it Z. We'll call it credibility Z, and that's found by PT divided by PT plus S over V. And then those are our credibility factors for each fleet. So now for each risk, we can now calculate the credibility premium per unit of risk volume. We call that PPR. And that's equal to Z times XT plus 1 minus Z times XB. Now you should hopefully recognize that as a weighted average, because what's happening is depending if this Z value for each risk tells us how much we should give, how much weighting we should give to the data for A versus the global data. So this is saying, for example, that since if you look at risk A, it has a credibility factor of 0.888. Yeah, so that means that we're going to give more weighting to the mean for A than for the overall mean, which is XB. Okay, so when we find the value, so because this would be 0.8 times something, this would be 0.13 or 0.12 times something. So there'd be more weighting will be given to the information, the data we have for A than for the overall data. Okay, and in fact, for all of them, because they're so high, credibility factors are so high, we can see that more weighting, when we're calculating the credibility premium per unit risk volume, we give more weighting to the data we have than for the particular fleet than for the mean for the overall fleet. That's what this credibility factor is telling us. So when we do that, there we have it. So our credibility factor, so credibility premium per unit risk volume for each of the fleets is here. So per unit of risk volume, we would expect to get. This is the kind of claims we would expect to get the claim. So for one policy, we would expect to get 302 pounds worth of claims in for fleet A. But for fleet E, for one policy, we would expect to generate 724.3741, which is what we would really expected. Because if we given the if we go back to look at this is the claims for each. You see there are a lot more claims for risk E than they were for risk A. So we would expect, obviously, the money or the claim amount to be greater. Now, suppose we knew that what the risk volumes were for the coming year. So how many policies we had for risk A, risk B, and so on and so forth. Then we can use our credibility premium per risk volume to estimate the total claims for each risk in the coming year. So what we're saying is, if we assume we're going to get 6 policies for A, 15 for B, 4 for C, and 10 for D and E, then we just multiply that vector by our credibility premium per unit of risk volume, and we get that. So we would expect total claims 1,180.12 for A, 5,950 for D, provided those were the volumes that we were going to have for the coming year. Well, I hope you enjoyed that, and I know I did. That was quite a nice exercise. I found R, and until next time, take care.